To go from standard to vertex form, at the moment, we need the vertex of the parabola. Previously, we found the vertex by rewriting the relation in factored form, solving for the zeros, then the axis of symmetry, and finally the optimal value. However, we discovered that this method does not always work. So we recently discussed how to use symmetry or partial factoring. So when our equation is in standard form, using symmetry, we let y equal c and solve for the roots. Using the roots, we determine the axis of symmetry. And using the axis of symmetry, we determine the optimal value. And from there, we would sub our h and k value into the equation in vertex form and use the a value from standard form. Today, we're going to look at a direct method from going from standard form to vertex form. So we can skip using factoring or using symmetry. But before we can continue, we need to understand what a perfect square is. So in example 1, we have 6 quadratics which are perfect squares. And to show you what a perfect square is, we're going to factor these 6 quadratics. So the first one is x squared plus 2x plus 1. So we need two numbers that multiply to a times c, which equals 1, and add to b, which equals 2. So two numbers that multiply to 1 and add to 2 are 1 and 1. And using these two numbers, we can now factor this quadratic. So we get x squared plus x plus 1. If we take the common factor out of the first two, we get an x plus 1. And if we remove the common factor out of the second grouping, we also get x plus 1. Removing the common factor of x plus 1 leaves us with x plus 1. And we notice we end up with x plus 1 squared. This is what we call a perfect square. Let's go to the next one. We need two numbers that multiply to a times c, which is equal to 4, and add to b, which is also equal to 4. We see that these two numbers are 2 and 2. 2 times 2 is 4, and 2 plus 2 is 4. So if we rewrite this, we get x squared plus 2x plus 4. Common factor out the first pair. There's a common factor of x. And in the second pair, there's a common factor of 2. Remove the common factor again. This time it's x plus 2. And we're left with x plus 2. So what we have is x plus 2 squared. So let's try this one more time. We need two numbers that multiply to 9, a times c, and add to 6. So the two numbers we see here are 3 times 3. And we'll be a bit quicker with this one. Our magic numbers are actually going to be in our factors. So we're going to get x plus 3, and this only works if the a value is 1, which gives me x plus 3 squared. So the next one, two numbers that multiply to 36 and add up to negative 12. So if you start seeing the pattern, we see this time our magic numbers are negative 6 and negative 6. So we end up this time with x minus 6, which gives us x minus 6 squared. E, if you go through it, you'll get x minus 7 squared, and the last one will get x minus 9 squared. So these are examples of perfect squares. Why are they important? Well, if you look at vertex form, we see we have a perfect square inside of vertex form. How do you know if a quadratic in standard form is a perfect square? So looking at those 6 we have above, there is a pattern in all of them that would let us know they are perfect squares. And the key is to look at the b value and the c value for each of them. One way we can explain this is by saying if we take half the b value and square it, we get the c value. So mathematically, if you want to write that out, that's b divided by 2 and square. So let's take our example here. We take negative 18 divided by 2 and square it, we will get 81. And if that is true, we have a perfect square. So using that, could you tell me what are all the c values for these quadratics to create a perfect square? So take a minute now, pause the video, and try this out. So hopefully you've tried these out yourself. So I'm going to tell you the first one. It's going to be 100. The second one is going to be 9. And the next one is going to be 25. So again, think about what we said above. To be a perfect square, we got to take half the b value and square it. 20 divided by 2 and squared it. Negative 6 divided by 2 and square it. 10 divided by 2 and square that number. So now you should be able to get the last three. So for D, I end up getting 16. For E, it is negative 5 divided by 2 and square it. Well, since that's a fraction, that's going to give me 25 over 4. And the last one, it is b divided by 2 and square. Well, what is that? That is b squared over 4. So to make a perfect square, we have to take half of the b value and square it, and that will give you the c value. So now let's talk about the method of completing the square. The method of completing the square will get us from standard form, y equals ax squared plus bx plus c, directly to vertex form, y equals ax minus h squared plus k. It's called completing the square because we're going to create a perfect square for this equation. All right, step 1. Factor the a value from the x squared and x term. So if we look at that, there's our x squared and our x term. We always factor out the a value no matter what it is. So in this case, our a value is 2. So that's going to leave me with x squared plus 6x. And I only factor out of those two. And the negative 5 is a spectator outside of the brackets. Step 2. Determine a constant that is needed to create a perfect square. So like we did above, we're going to take half of b divided by 2, and we're going to add and subtract this value to the equation. So it's going to look like this. We have our 2. We have our x squared plus 6x. We have our negative 5. If we take half of b, which is 6, we divide it by 2, and we square it. 6 divided by 2 is 3. So that's going to give us 9. We're going to add 9 to this equation, but in order not to change the equation, we need to subtract 9. So what we've done is we've added 0. So step 3 is to remove the negative constant using the distributive property. So we have 2x squared plus 6x plus the 9 minus the 9 minus 5. We are going to distribute or kick out the negative 9. We're not going to expand any other terms, just the negative constant. And if we do that, we get 2x squared plus 6x plus 9 minus 5. And 2 times negative 9 is negative 18. The next step, we're going to factor the perfect square and simplify. So remember, the perfect square is right here. We made the perfect square. So let's look at that separately. That's x squared plus 6x plus 9. So we need two numbers that multiply to a times c, which is 9, and add to b, which is 6. So the two numbers are 3 and 3. So that gives us x squared plus 3x plus 3x plus 9. And if you know the shortcut, you can go directly to the answer. If we common factor the first two, we get x plus 3. Common factor the next two, we get factor of 3, and we're left with x plus 3. Factor out the x plus 3's, and we're left with x plus 3, which gives me a perfect square of x plus 3 squared. So now we have 2 x plus 3 squared, that is what this equals to when you factor, and then a minus 5 and minus 18 gives me minus 23. So we factored the perfect square, and we simplified by collecting the like terms. So therefore, our equation in vertex form is y equals 2 x plus 3 squared minus 23. And that is the method of completing the square. Now with the quadratic rewritten in vertex form, we know what the vertex is. The vertex is our h and our k, negative 3 and negative 23. And now that we know the vertex and we know the a value, we can actually do a quick sketch of this parabola. So using our vertex of 3 and negative 23, and knowing that our a value is positive, we see we have a parabola that opens up and crosses the x-axis at 2 points. So let's practice completing the square a couple more times. So starting with the next expression, y equals x squared plus 10x plus 30. So we get y equals, common factor out the a value from the x squared and x term. So this time the a value is 1. So we're left with x squared plus 10x, leave some space, plus 30. We need to create a perfect square, so we need to take our b value divided by 2 and square it, which in this case our b value is 10. And if we do 10 divided by 2 and square it, we're going to get 25. So we're going to add a 25 and minus a 25. We want to kick out always the negative constant. And if we do so, we now have 1 x squared plus 10x plus 25 plus the 30 that was already there. And we kicked out a negative 25 times 1, which is negative 25. The next part, we need to factor the quadratic and collect our like terms. So to factor the quadratic, remember we're going to factor x squared plus 10x plus 25. We need two numbers that multiply to 25 and add to 10. And the two magic numbers we get are 5 and 5, and I'm just going to use the shortcut. That means we get x plus 5, which is x plus 5 squared. So here we have x plus 5 squared. So again, if we want the vertex of this quadratic is negative 5 and 5. So remember the negative 5 came from here, and the k value or the y value came from the constant. All right, next example. Factor out the a value from the x squared and x term. So we get y equals 6, x squared minus 2x. Notice we only factored out the constant, plus 7. We need to make a perfect square. So b divided by 2 and square it equals negative 2 divided by 2 and square it. So that tells us 1 is going to be our number. So we're going to add 1 and minus 1. Again, we're going to kick out the negative constant. So we get 6 x squared minus 2x plus 1. We kicked out the negative. That's 6 times negative 1, which gives me minus 6. And finally, we're going to factor and collect our like terms. And we're going to factor this time x squared minus 2x plus 1. Two numbers that multiply to 1 and add to negative 2. Our magic numbers are negative 1 and negative 1, which means this will be x minus 1 squared. So we get x minus 1 squared here, which tells us our vertex is 1 and 1. And on to the last one. So again, y equals, common factor out first. That's negative 3 x squared plus, or in this case, minus 4x. So we common factor out only the a value. This time we have a plus 0 on the outside. There was no constant to start. To make this a perfect square, we need to take negative 4 divided by 2 and square it. So that's going to give me 4, and we need the minus 4. We are going to kick out the negative constant. So we get negative 3 x squared minus 4x plus 4 plus the 0. But then we kicked out a negative 4. We times it by negative 3. So that's going to give us a plus 12. And now all we need to do is factor and simplify. So we get negative 3. If you factor this, you get x minus 2 squared, and you can try that on your own, plus 12. So this means for our last example, our vertex is 2 and 12. So the nice thing about completing the square, in 3 lines, we get our vertex form. And in vertex form, we now have our vertex. So we get our vertex form, we get our vertex, and with this we can also create a sketch. So we see that we have a point at 2 and 12. That's our vertex. The a value is negative, so this parabola opens down and has 2 zeros.